Welcome to Mission Apsc AG YouTube channel. আজি আপোনালোকৰ কাৰণে লৈ আহিছো strength of materialৰ 50টা MCQ questionৰ discussion. এই question সমূহ APSCৰ আহিবলগীয়া assistant engineer, junior engineer বা তেনেকুৱা equivalent exam সমূহৰ কাৰণে যথেষ্ট গুৰুত্বপূৰ্ণ হ'ব। যদি ভিডিওটো চাই আপোনালোকে উপকৃত হোৱা বুলি ভাবে কাইন্ডলি ভিডিওটো লাইক কৰিব, চেনেলটো সাবস্ক্ৰাইব কৰিবলৈ নাপাহৰিব। First question to মই লৈছো the bending strain is 0 আমাক সুধিছে bending strain ক'ত 0 হয় so basically যেটো আমাৰ neutral axis হয় neutral axis ত bending stress as well as bending strain 0 হয় যদি আপোনালোকে beam bending or formulas বিলাক দেখিছে বা beam bending or theory বিলাক দেখিছে তেতিয়া হলে দেখা পাবো generally strain is varying in linearly and at neutral axis the strain is 0 that means neutral axis of strain to 0 hoy the neutral axis basically ki hoy it is a line of intersection of neutral plane or neutral layer on a cross section the neutral axis of the beam passes through the centroid of the section at the neutral axis both bending stress and bending strain is 0 yet a question to bending stress huda holeo answer to neutral axis e holeten next coming to question number 2 thudise Tenacity মানে কি হয় tenacity এর আনেটা নাম হইছে ultimate stress মানে কি it is the greatest load or maximum loads that require to fracture the material divided by the area of the original cross section so original area greatest load pe jodi ami divide kori diu tetia hole ami pao jitu stress that is called ultimate stress aru ultimate stress ok ami tenacity value jana jay so option b to correct hoi jabo ultimate stress next coming to next question is the bending stress in a beam is so generally bending stress to beam or bending moment or logot kenuka dhone related hoy hudi ase it is basically equal to the bending moment why because the bending stress is equal to the bending moment per area so per area jiman bending moment lagi ase that will be basically bending stress so hence as the bending moment increases or decreases the same amount is also noticed in the bending stress suppose bending stress is increases by 5% the bending moment is also increasing by 5% so option D to correct ho jabo equal next question number 3 hodise basically eta numerical hodise radius to uliabo dise aluminum strip or width to dise 300 mm or this is 300 mm wider and 40 mm thick dia ase if the maximum stress in a strip is not to exceed 40 newton per mm square then what is the radius so ami directly bending or jitu formula hoy simple bending theory that is E by R is equal to F by Y etu ami apply korim aru tar karone ami R or value to kiman pai jam E into Y into F what is E is given as basically 7 into 10 to the power 5 right so etu asile amar newton per mm square jodi ami kilonewton per mm square likhibo jao or you have to convert it 7 into 10 to the power 2 kilonewton per meter square right kilonewton per mm square right so this is basically newton per mm square ase aru y value to amak dia ase what is the value of y is basically 40 mm thick tar adha to hobo right so that will be 20 and what is value of f is nothing but it is given 40 mm right so this cancel out 2a to dubar gol so ultimately 2a 70 k bar jabo basically see here you can write as 7 into 10 to the power 5 ok ami likhibo paru 70 into 10 to the power 3 right so if I convert it into kilonewton per meter square and this is 2 so 2a70 gusi jabo 35 mm ultimately results will be coming in meter 35 meter option C to correct ho jabo next question number 4 ot ahise dash of a beam is measure of resistance against deflection or against measurement ok ami stiffness bili ko option B a beam is said to be a strength when the maximum induced bending and shear stress are within the same permissible stresses stiffness of a beam is measure of its resistance against the deflections next section modulus or value to khube common question BD square by 6 hoy basically section modulus is what Z is nothing but I by Y that is moment of inertia divided by the distance of the extreme fiber that is basically section modulus or rectangular karone BD cube by basically 12 hoy R value and Y value to basically hoy D by 2 so ultimately the answer will coming as BD square by 6 next the strength of the beam or strength to kihor upor directly depend kore modulus section or uporot option A to correct hoy the ratio of moment of inertia to the distance to the extreme fiber is So basically moment of inertia যেটো হয় তাক যদি এক্সট্রিম ফাইবারে ডিভাইড কৰি দিও the value which is come is nothing but modulus section. The beam is stronger when the section modulus is more, and whereas the beam is basically less when the modulus or section modulus is less. তেতিয়া হলে the beam of same strength mean section modulus is same. আৰু যদি strong কেতিয়া কম যেতিয়া section modulus তো বেছি থাকে আৰু section modulus কম হলে আমি কম this is a weak beam, right? So option A to correct হৈ যাব. Next, the in a cantilever beam there is a stress above the neutral axis. So generally cantilever beamৰ ক্ষেত্ৰত tensile strength to ulta হৈ যায়, tensile strength to ওপৰত আহে আৰু compressive strength to তলত আহে, right? In a cantilever beam maximum compressive stress occurs at the bottommost fiber and maximum tensile stress occurs at the topmost fiber. বহুত বাৰ এক্সামত কোৱেশ্চন সুধিছে কি in a cantilever beam where the compressive stresses occurs and where the maximum tensile stresses occurs. So maximum tensile stress topmost আৰু minimum or maximum compressive stress হৈ যাব bottommost. Next, question number 7 out আমাক সুধিছে the curvature of the beam is equal to. So curvature of the beam is basically m by ei because your formula is something like that. E by r is equal to m by I is equal to f by y. So আমাক সুধি আছে what is the curvature? Curvature to আমি basically m by ei because 1 by r is m by ei and 1 by r is nothing but it is known as the curvature of the beam, right? Next, the maximum slash stress occurs at the topmost fiber of the simply supported beam. So যদি simply supported beam হয় তেতিয়া উল্টা হয় মানে cantilever কে উল্টা হয় compressive strength topmost fiber ত আহিব আৰু bottommost fiber ত tensile strength আহিব. Next, what is the variation of bending moment if the simply supported beam carries a point load at the center? যদি point load at the center লয় for a simply support beam, what will be the variation? So yes, so mainly আমি কি কৰিব লাগিব আমি we have to draw the bending moments and bending moment is something like that আৰু point load এই value to কিমান আহে WL/4. So the arrangement is nothing but the shape is nothing but triangular shape, option A. Next, question number 9 ole aise a simply supported beam of span x meter carries a UDL W per unit length over the entire span. The maximum bending moment occurs. So center occurs কয় সবে জানে that is WL/8. Mainly bending moment diagram to এনুকা হয় এটা maximum value to হৈ যায় WL/8. Next, question number 10 ত সুধিছে positive bending moment is known as positive bending moment বললে কি বুঝা positive bending moment হৈছে sagging moment whereas negative bending moment is hogging moment. Okay, so the positive bending moment of a section is considered because it causes convexity downwards. Such bending moment is called sagging moment and it is also known as positive bending moment. Okay, next we have bending moment in a beam is maximum when the shear force যত 0 হয় তাতে bending moment to maximum হয়. The bending moment occurs in a beam when the shear force at that section is 0 or change its sign. 0 হয় বা তার sign to change করে because that point is nothing but counterflexure. কেতিয়াবা খুদে কি counterflexure point কি হয় when where the bending moment change its sign. So mainly option C to correct হৈ যাব এই question to respect. Next question লৈ আহিছো a cantilever beam subjected to a point load at its free end and the maximum bending moment develops at the slash of the beam. So yete correct answer to hobo as the moment of the product of the moment is nothing but it is the product of perpendicular distance and the force. In cantilever beam at its free end the moment will be 0 as there is no distance, but at the fixed end the moment is maximum, that is W into L. So amak khudise maximum bending moment kot hobo cantilever, so the maximum will be at the fixed end, option B to correct ho jabo. Next, the stress corresponding to the strain in the stress strain curve of mild steel or strain curve to bahut important hoy. The stress which is corresponding to 0.2% of the strain in the stress strain curve of mild steel is known as proof stress. So proof stress koy generally 0.2% of the strain, right? So option A to correct হৈ যাব. The maximum stress is generally taken as yield stress and the 0.2% of the strain is nothing but proof stress. Next, modular ratio method to another নাম আছে হিন নামটো সুধিছে that is working stress method. The stress in the steel is linearly related to the stress in adjoining concrete by constant factor called modular ratio. So কেতিয়াবা সুধে what is modular ratio? Modular ratio is basically the ratio of the modulus of elasticity of the steel with respect to the concrete. Working stress method is used for determining basically মডুলাৰ ৰেচিঅ' মেথডৰে আন এটা নাম হৈছে ৱৰ্কিং ষ্ট্ৰেছ মেথড তাৰপিছতে আহিলে দ্য ডিজাইন কম্প্ৰেছিভ ষ্ট্ৰেংথ অফ দ্য কংক্ৰিট দিছ ইজ ভেৰি ভেৰি ইম্পৰ্টেণ্ট জেনেৰেলি ডিজাইন ষ্ট্ৰেংথটো 0.466 টাইমছ অফ কেৰেক্টাৰিষ্টিক্স কম্প্ৰেছিভ ষ্ট্ৰেংথ অফ দ্য কংক্ৰিট হয় চ' দ্য কম্প্ৰেছিভ ষ্ট্ৰেংথ অফ দ্য কংক্ৰিট ইজ অফ দ্য ষ্ট্ৰাকচাৰ ইজ এজুম টু 0.67 টাইম অফ FY right but we have to incorporate the partial factor of safety that is 1.5 for concrete so 0.67 of 1.5 এৰে যেতিয়া আমি ডিভাইড কৰি দিম we'll get 0.446 FCK ইয়াতে টাইপিং মিষ্টেক হৈছে 0.446 হ'ব লাগিছিলে বা 0.45 ক্লোজলি যদি লিখিব খোজা so অপচন সি টো কাৰেক্ট হৈ যায় for this question next তাৰপিছতে কংক্ৰিটৰ পাৰ্চিয়েল ফেক্টৰ অফ সেফটি কিমান 1.5 ষ্টিলৰ উদা হলে 1.2 কেতিয়াবা শুনে why steel have less partial safety of factor as compared to concrete because steelত quality control to বেছি হয় that's why তাতে ইমান ভেৰিয়েশন নালাগে কম হলেও হয় but কংক্ৰিটৰ ক্ষেত্ৰত বহুতখিনি ফেক্টৰ ডিপেন্ড কৰে লাইক কম্পেকশন inadequate curing improper batching and mixing next এটা numerical আহিছে a simply supported beam of span length 8 meter carries a UDL of 16 kilonewton per meter and point out 60 kilonewton acting at its center maximum shear force hodise so basically maximum shear force for a simply supported beam which having UDL is basically WL/2 right but at a point load lagi ase so that's why point load is 16 and because of this 16 kilonewton we have the loading is 16 into 8 into 2 16 is basically UDL load 8 is distance and divided by 2 so that this part is come for UDL and this 60 is come for mainly point load so mainly we will get answer as 94 kilonewton option D to correct hoy next question number I guess 12 a spring used to absorb the shock and vibration is called as conical spring leaf spring this is spring torsion spring so yare bhitor correct answer is leaf spring a leaf spring is used to absorb shocks and vibration and a spring in brakes and classes are invariably used in order to apply force tar bisore ahile modulus of resilience ki hoy modulus of resilience is basically resilience at the proportional limit so the resilience per unit volume is defined as modulus of resilience basically and it is a property of the material the modulus of resilience is equal to 1 MPa for steel with a proportionality limit of 200 MPa so resilience at proportional limit is known as modulus of resilience next the failing of a very long column so bahut dangor long column jar height to bahut besi tar karone mainly kuntu fail kore is it crashing collapsing buckling or twisting option C to correct hoy buckling the members considerable long in a compressions of lateral dimensions are called long column the members essentially fail by buckling or crippling to bending according to Euler's formula the long column can be determined okay Euler's formula use kora hoy so mainly IS could eta question minimum thickness of the web should not be less than so as per IS 456 the minimum thickness of the web should not be less than D/250 option A to correct elongation of mile steel or minimum elongation of 23%. Next is shear stress at the topmost fiber of a rectangular section. So rectangular section or topmost fiber of shear stress kiman hoy hodise answer hoy 0. So mainly the maximum shear stress occurs at the neutral axis. So hence we can say that the shear stress at the topmost fiber of the rectangular section will be 0. So we have a formula of shear stress that is if the distance is y from the neutral axis this is the formula and when y is equal to 0 we will get the maximum shear stress right next question number next question to question number I guess 14 the maximum shear stress distribution is 33% more than the average shear stress distribution so mainly maximum shear stress to kiman hoy 4/3 times 4/3 times mane kiman around 33% next a circular beam dia ase 0.25 mm diameter is subjected to a shear force of 10 kilonewton calculate the value of maximum shear stress area u dia ase so diameter dia ase area dia ase so you have to find the basically what is maximum shear force so we know for circular cross section 4/3 into average shear stress mane force per area force is given 10 kilonewton so eto jodi ami newton or anu 10,000 Newton divided by area is 176 meters square. So ultimately we have to convert proper unit conversion and we will get 0.75 Newton per mm square. Option A to correct ho jay. Next question number 15. Yatwe eke hudise calculate the modulus of the section for hollow circular column of external diameter 60 mm and 10 mm. So yate calculative question hoy. Yate আমি এটা ফর্মুলা লগাব লাগিব, that is pi d4 minus d4 divided by 32d. So everything is given. So basically small d we can find as যেহেতু diameter 16, thickness 10 meters, so 16 into 2 times of t কৰি দিলে আমি small d পাই যাম. So everything is known, so we can able to get the value of modulus of the section. We will get 170 meter as a answer. Option A. Next, the modular ratio of M20 concrete gate, M20 কাৰণে formula is 280 by 3 into sigma CBC. So here basically if you put the value 280 into 20 divided by 21, since the sigma CBC value is 7 Newton per mm square, so we will get 13.33. So we will get as 13.33 according to this formula. Next, the maximum shear stress in the rectangular section. Rectangular section or khetrot average shear stress or 1.5 times by 3 by 2 hoy, right? Option D correct hoy. Next question, circumferential stress is the same as of, so circumferential stress কাৰ লগত একে হয়, hoop stress আৰু circumferential stress একে হয়. Next, maximum shear stress in thin cylindrical shape. যদি আমাক hoop stress সুদে PR by T হয় আৰু longitudinal stress হলে PR by 2T হয়. So hoop stress is basically twice of the longitudinal stress হয়. So ultimately আমি maximum shear stress to হৈ যাব PR by 4T as a answer. Next, question number 25. A steel beam 200 mm wide and 300 mm deep. The beam is deeply supported and carries a concentrated load of W. If the maximum stress is 2 Newton per mm square, what will be the corresponding load? So directly I formula to apply koribo paru, 3/2 force per area. 3/2 force is given as W divided by 200 into 300. This is the area. So we can get the weight as 80 kilonewton. So just amar unknown to asle force, ami force to uliyai lolu 80 kilonewton. Next, for a circular section, the maximum shear stress is equal to the slash times of average stress. So the answer is 4/3, right? Next, a round steel rod 100 mm diameter bend into an arc of radius 100 meter. What is the maximum stress of the rod? So tar karone ami mainly ki koribo lagibo, we have the value of D, we have the value of Y, we have the value of R. Directly ami flexure bending jitu formula asle, simple bending formula use kori pele we will get as 100 Newton per mm square as a answer. Option C to correct. Next, shear stress distribution over a rectangular section. Rectangular section or karone shear stress distribution to parabolic hoy. Okay, 1.5 times hoy, eto to ami discuss korile. Option A to correct hoy jabo. Next, question number we can say 30. Determine the shear stress at the level of neutral axis of the beam has a triangle cross section having base and altitude h. Let the shear force. Shear force will be 8F/TB/h. Mano rakhibo formula to. Next, at slash the shearing stress in the beam is maximum. Similar question ahise. So it is neutral axis of shearing stress to maximum hoy. Next, on a bending of a beam, which is the layer which is neither elongate nor shorten, that is neutral axis. Next question, what is the expression of the bending moment? So equation m/I is equal to sigma by y is equal to E/R. This is the bending equation, right? Next, stress in a beam due to simple bending, stress to directly proportional hoy. The stress directly proportional to the load. Here the load is in terms of bending, so stress is directly proportional to bending or logot stress to direct proportion hoy. Next, a beam is said to be uniform strength. So a question to ekbar exam ot ahi goise APSC ki beam to jodi uniform strength thake, that means what? Bending stress is the same at every section along its longitudinal axis. Beam is said to be uniform strength if at every section along its longitudinal axis if the bending stress is same, right? Option D to correct ho jay. Next, question number 35. What is the relations between maximum stress induced due to sudden loading to the maximum stress to the gradual loading? So sudden loading or karone 2 times of P/A hoy jay aru maximum gradual load or karone P/8 hoy. So here kuntu option correct hoy jabo, because amak khudi ase the relationship between the maximum stress induced due to sudden ot amar 2 times hoy jay as compared to gradual loading. So maximum stress in the sudden is twice that to the maximum in the gradual. Option C to correct hoy jabo. Next, A bar of cross section of A and length L is subjected to axial load. The strain energy is আমি জানো deformation is PL by AE বা WL by AE, but strain energy is nothing but the deformation into W by 2, right? So deformation is WL by AE and W by 2 we have to multiply, so ultimately we will get WL square L by 2 AE. So option C2 correct हो जाए. Next question number mainly 46. A rectangular block of size 400 mm into 50 mm into 50 mm is subjected to a shear stress of 500 kg per centimeter square. If the modulus of rigidity of the material is given, what is the strain energy? So strain energy karone amar formula ase tau square V divided by 2g. So tau value is 500 square and V value 2 into 10 to the power 6 into 40 into 5 into 5. So ultimately we will get 125 kg per centimeter. Next, PL cube 3EI is the deflection under the load P of a cantilever beam. What will be the strain energy? So average force or logot ami displacement multiply koribo lagibo. So amar deflection dia ase tar logot average force is nothing but P by 2, right? So we will get as P square L cube by 6EI. Option B2 correct ho jabo. Next question number 48. 3 sections in a beam of equal length of 100 mm. All 3 sections pull axially with 50 kN due to it elongate by 0.2. What will be the resultant strain? So strain is nothing but DL by L. So 0.2 divided by L is nothing but 100, right? So 0.02. This strain is only for one section, but we have to apply principle of superposition because we have 3 individual strain. That is algebraic sum koribo lagibo 0.2 0.2 0.2. We will get 0.006. Option C2 correct. Next question number 49. Which law state the number of loads acting on a body, the resulting strain according to the principle of superposition will be algebraic sum of strain caused by individual load. Eto hoise অলপ আগতে আমি apply কৰি আহিলো principle of superposition. Next, elastic limit is the point up to which load is removed original volume and shape are regained. Option C2 correct হৈ যায় for question number 49. Next, last question, that is question number 50. Which point on the stress strain curve occurs after the proportionality limit, that is elastic limit. Just elastic limit to cross korar pishot we will get the proportionality, just proportionality limit to cross korar pishot we will get the elastic limit. So hekhini asile important 50 ta MCQ question or discussion. Jodi ei video to se apnaloke upokita howa bili bhabe kindly video to like koribo, friends ok share koribo. Thank you for watching.